Hi, everybody. My name is Paul Lammertsma. I am a developer relations engineer in Android at Google, and I'm super happy to be back in Berlin. It's one of my favorite conferences, DroidCon in Berlin. Also great to be back in person, of course. I'm sure we're all very happy about being able to attend in-person events again. I want to spend the next 40 minutes or so talking about large screens and optimizing your app for large screens. And to start with, I want to briefly touch on what are large screens, right? Because I also work in TV, which is not large screen, very confusingly. By large screens, I'm referring to foldables and tablets and laptops like Chromebooks. And it's these devices that we've seen a growing popularity of using Android apps that are optimized for large screen form factors. So starting with Android 12L and building upon it into Android 13, the platform makes it much easier to interact with your apps in new ways with using new form factors, going beyond the traditional sort of like portrait-locked phone experiences that we're so very familiar with. So to help you along with that path, what we've put together is the material guidelines to help you build great apps really optimized for these differentiating form factors, as well as quality guidelines for evaluating the level of support and what your app provides on the large screen itself. So we have a couple of great resources here, and today I'm going to walk through this set of quality guidelines and explore the tools and the techniques that we currently have available for you as developers on your journey to optimize your app for the large screen. So one thing I want to call out before I do that is how the quality guidelines also tie into Google Play Store updates. So we have some updates coming in the coming months where we'll begin updating apps that updating our featuring and ranking logic in Google Play so that large screen devices are prioritized for the high quality content for apps and games. And what I mean with that is we'll have a tailored experience where the best-in-class quality apps on large screens will really stand out to consumers on Google Play. For apps that don't meet basic app quality guidelines, we will be updating content alerts to users for large screens to help users understand and set their own expectations of what their app that they're installing on their large screen might look like after installing it. So you can think maybe they'll get a little warning that the app is not optimized for the device. And finally, users will also be able to see ratings and reviews split by device type. So not just for large screens, but also between Chrome OS and Wear and Auto or Automotive. So the large screen quality guidelines really define 3 levels or 3 tiers of large screen support. When we look at the base tier, like the tier 3 basic support, we're talking about making your app just in the very basic sense, ready for large screens. Now, tier 2, as we go beyond, is better support with an app generally being optimized for the larger screen, making better use of the screen real estate. And then finally, the open-ended sort of tier 1, which is really about differentiated experiences. You can see that as like where an app has the best large screen support and is really using the form factor to its fullest advantage. And probably, to be honest, you know your business pretty well, so you probably have a pretty good idea what you want to do, but I have some examples to show you at the very end of the presentation. So while I'm talking about the different tiers, and I'll step through it kind of in 3 different parts of this presentation, I really encourage you to think about your app, like how it exists today, and which steps you can be taking to really improve your user experience, to take those maybe quick wins, or to maybe like longer, more ambitious goals to make your application ready for foldables and tablets and laptops. So starting with tier 3. The first level of large screen support, really, getting your app basically ready for the large screen. So what does it take for them to reach the criteria for tier 3? So in the basic sense, it's all about the app just behaving in such a way that it behaves okay, it behaves like appropriately when things change, like the orientation changes or the screen size changes, input modes might be changing, and you're not making any kind of restrictions to the size of your application or the orientation. And you have to think about, like, as the user is rotating the device or when they're unfolding or folding the device, or resizing it in multi-window mode or on a laptop with freeform mode, how the app will be preserving the user's state and remain functioning properly. I'm not necessarily referring to how the UI might look. We'll see that and how that can be optimized in Tier 2, but just basically that the application retains its state and behaves properly. Now, especially if an app is currently locked into an orientation that declares aspect ratio limits, getting to Tier 3 really requires you to challenge your assumption that you might have made about how your app might be positioned or how you interact with, how you expect users to interact with it while it's open. So the real mindset you have to have about this is challenge assumptions about, for instance, locking into orientations and locking aspect ratios and screen sizes. So for instance, on Android 12L and 13, we've brought this improved taskbar that you see here at the bottom for app switching. And one of the great things that you can do is you can make it really easy to basically drag an application from the taskbar to enter into multi-window modes and split screen mode. So this is very important to test your app in this behavior because users are going to begin to expect it because it's so in the forefront of the user experience. So it's very important here that you as a developer make sure that your application behaves well with resizable windows. And if you're using your application in multi-window mode, it also means that other apps might be using similar resources in parallel. Things like the camera or the microphone may be used by two applications at the same time. So it's also essential for you to add the correct logic for your app to use controlled access. Now, suppose that you have a device with a display size bigger than 600 dp, and you're locking the orientation of your activity to portrait. So when a user then rotates the device into landscape on a device of that display size of 600 dps, what will happen is they'll enter into this new compatibility mode from Android 12L and onwards. So if your app falls into this category, you need to be sure that the behavior of your app in compatibility mode is compliant. So again, making assumptions that you might have had about what you would expect to occur with portrait mode may no longer be valid in this modality. So beyond Chromebooks, also tablets now are seeing lots more use with peripherals, including attached keyboards and mice and styluses. So a great app user experience also means supporting these input modes in addition to touchscreen support. So for Tier 3, an app should basically provide some basic degree of support here. I'm not talking about optimizing for hover states with styluses and that sort of thing. I'm just talking about make sure that it's functional. Make sure that users can reach focusable elements using the keyboard. Make sure that, for instance, drag and drop is supported with a mouse as well. We'll see later there's a lot more that we can be done with these advanced forms of input, though. So one of the most directly applicable cases where some of your assumptions might be challenged here is with regards to the camera behavior and how it interacts with the device orientation. So maybe just a quick show of hands. I'm just going to do this once in this presentation. I'm not going to make you raise your hands all the time. But who here in this room is avoiding dealing with viewfinder orientation in a camera app by locking their app to portrait? See 2 hands, 3, 4. Okay, there are a couple of guilty folks here. All right. So if you're doing that, your camera app, if you're doing this inside your camera app, so locking the portrait orientation, and you're not handling configuration changes, your camera preview may be broken in compatibility mode. To understand why this is happening and how to fix it, we have to introduce a couple of concepts involved in correctly handling the orientation and window size. Let me just introduce it. I'm going to describe this thing, I'll call it like the natural orientation. It's going to be like a reference point for what the orientation is of what a user would naturally expect from the device. For instance, like on a laptop, with a webcam, it's going to be the landscape orientation, and on a phone, it would be the portrait, and a tablet might be one or the other. But in any case, so this is going to be our natural expectation. So starting from this definition, we can define 2 other concepts. We'll call it the camera orientation and the rotation of the device, or the device rotation. Okay. So if we call the camera orientation the angle between the camera sensor and the natural orientation of the device, then this is likely dependent on how the camera is physically mounted inside the device. And in the past, we always talked about this usually being aligned with the long side of the screen, so there's a physical relationship between how the camera was oriented and what the orientation was of the device. But what about now with a foldable device, where the device can physically transform its geometry as you unfold it? It changes everything, right? And for this reason, starting from API 32, this field is not static anymore, and it's now instead can be dynamically retrieved from the camera characteristics. Now, the other concept that I wanted to talk about is the device rotation. So the device rotation measures how much of the device is physically rotated from its natural orientation. Right? So since we usually only want to handle 4 orientations, we can consider these angles as multiples of 90 and then get the information of multiplying the value from the rotation by, from the value of display.getRotation. Just multiply that by 90. So let's put together a function that computes the rotation required in degrees to transform from the camera sensor output orientation to the device's current orientation. Now what we'll do is we'll take the camera characteristics and the current device rotation as parameters. And then we can start by calculating the difference between the sensor orientation and the display orientation, ensuring that the result is held within 0 and 360 degrees. But this already isn't sufficient, because there's another thing. What if the camera is facing the front or the back of the screen, right? So what we can do there is, if the rotation needs to be corrected for counterclockwise or clockwise, depending on which way the camera lens is facing, we can simply flip the sign on the rotation, right? So here what I've done is I've checked the orientation, the facing direction of the lens. If it's facing front, I flip the sign, otherwise I leave it be. So finally, we can then calculate the difference between these two concepts and constrain it once again between 360. All right, great. So we've handled for the orientation, but it doesn't guarantee that the camera has a correct preview. Think again about multi-window mode, right? Maybe in multi-window mode, you need to display a landscape-shaped camera output on a portrait-shaped window. So you'll either need to crop the image or scale it somehow to match the aspect ratio. Otherwise, without the right transformation, you may end up with a shrinked or distorted preview like you see here. So correctly transforming the image for every possible scenario is actually really challenging. But we have published a step-by-step guide that provides provides a step-by-step guidance in the Camera 2 APIs to accomplish this. I've linked it here in the slides. But if you don't need access to something low-level like Camera 2, you don't need these low-level camera APIs, then what's maybe easier to use is the Jetpack Camera X library. And what this does is it actually transforms the preview for every screen size and handles the camera lifecycle. So also the viewfinder handles configuration changes accurately, and it controls the camera access for multi-window. So all of that is basically taken care of for you. And better yet, we actively test this on many different devices and many different form factors. So we're always vigilant and monitoring how this is behaving on different devices. So we're doing that work for you. Okay, moving on from camera-specific issues. There are other common issues that we see with apps regarding supporting configuration changes. One of those is, again, assuming that you have to avoid to deal with the configuration changes by locking your app into portrait. That doesn't mean that you are that prevents you from receiving configuration changes at all, right? It might just result in crashing or losing state when those configurations happen, even when you don't expect them to. Again, for instance, because of folding or because of a rotation change, you still have the portrait to landscape. The configuration changes will happen now, whether you like it or not. So the goal here is pretty straightforward. If the user is rotating their device or the app is being resized, look, it can be super frustrating as a user when something is lost in their state. Imagine you are in a chat app or you're drafting an email or something like that, and you rotate the device and the body of your message is lost. Super frustrating, right? So it can be smaller pieces of state, like that example. So information like partially entered into a form, or where you are in a scrolling list. Like maybe you've gone shopping somewhere and you've scrolled really far down the list and you rotate the device and you're back at the top. But it's also more significant app state issues, like the user's place inside the navigation of your entire app. That could be confused, especially if you think you have a list detail in landscape orientation, but you don't in portrait. Maybe you navigate away from where you were before. It can be very frustrating. Now, admittedly, actually achieving this goal is pretty hard. The one reason we have so many conversations about application architecture is because it's so hard. And it's no small part, the navigation can be considered a part of the user state. So we're going to revisit this concept in Tier 2, where we can look at some better navigations for large screens. But the good news is that there are a lot of tools that we can use, depending on the technology that your app is using. So all of these are ultimately backed by the application's activity saved instance state, right? For information, where the state is of your activity, your fragment, or your view. So you're just basically hooking into that directly. In a view model, you can use the save state handle to persist state through the configuration changes and even process death. And it's worth pointing out that the save state handle is also injectable with HILT, by the way, so that's pretty cool. And in Compose, there's Remember Savable and the Saver APIs, which provide idiomatic ways of saving pieces of data in the saved instance state. And also automated testing for this. We have a way of providing automatic testing for saving and restoring of state, so you can verify the behavior through hooks of the activity scenario. And in Compose, and that's what I wanted to look into now, we have the state restoration tester. So just for some context, the state restoration tester actually wraps a Compose test rule. So what I've done here is I've thrown together a little test, just a very simple unit test here for simulating, what is this? I'm incrementing a counter, right? So I'm using a Compose test rule. So I can alter this test. I've gone ahead and I've replaced these Compose test rule with a state restoration tester. And the neat thing is that any calls into Remember Savable inside this state restoration tester's set content are saved and restored when we execute emulate saved instance state restore. So now what this test does, it actually validates that the incremented count is actually saved through the restoration. And it's important to call out here, by the way, I'm using Remember Savable. If I replace this with just Remember, this test would fail because after restoring from the instance state, the count would still be 0. All right, cool. So now this is an architecture talk, but I am going to move on. One last thing that I wanted to mention about these changes to get to Tier 3 is that one thing I wanted to mention about this, like all of these things that we talked about so far is not specific to large screens, right? These are just actually just in general good things to do as an Android developer. Apps that handle different orientation and configuration changes correctly will be more accessible and just outright perform better, It's just going to be a better app in a variety of scenarios. Changing locales, changing font sizes has nothing to do with large screens, but also those will trigger configuration changes. So it also just means that we will just have a better app experience, but as a consequence, you'll also be large screen ready. So yeah, again, if you haven't already, I encourage you to try, challenge where your app stands today, disable that orientation lock, change, remove any of your aspect ratio locks and see how your app actually fares today and what it will take to get your app to Tier 3. Now, let's see where we are with the how we can use the screen real estate while actually saving it to the user state. So an app meeting Tier 2 has optimized its UI to take full advantage of the screen space. And the way that we can do that is through adaptive layouts. What that effectively means is that we're making more use of the available screen space and showing more content. Normally what you would have probably in your portrait locked phone app is some content would be hidden away in menus, or you'd expose things only through context menus. So here, Tier 3 support has really set the foundation, but the logic and the state is being put in place because of all the work we did in Tier 3. And now, as we move forward to Tier 2, we really look at how can we optimize that UI to bring those hidden components out and give them a good place in the screen real estate that we have. So I keep on mentioning screen state available to the app. I should probably explain how we can differentiate screen classes. The preferred way to determine the screen space available to your app is through the current window metrics. So we have the window metrics calculator from the Jetpack WindowManager library. And compute current window metrics is the most relevant for your application. So you also have compute maximum window metrics. But we're mostly interested in returning a value that corresponds to the amount of screen real estate that is available to your app, not the entire screen. So the idea being that the physical size of the display isn't really relevant to what makes sense to be able to display to your user. A good example of this is a freeform application on a tablet or multi-window mode on, freeform application on a laptop or a multi-window mode on a tablet. So once we have the size of the window, we want to deal with those arbitrary dimensions in a reasonable way. And to do this, we've partitioned the possible window sizes into 3 different classes: compact, medium, and expanded. Those breakpoints partition like common display device types and give them these specific names. And compact width size corresponds to pretty much all phones in portrait mode. Really, the definition here is like window size width less than 600 dps. And the medium width size then corresponds to tablets and the inner displays of foldables when they're in portrait mode with a window size between that 600 mark and the 840 dps. And then finally, we can consider expanded, that anything that goes beyond. So it would be really those tablets and foldable devices that are being held in landscape, which would be probably 840 dps or more. Now, for Compose specifically, the Material 3 window size class library takes care of both of these steps because it allows us to consume the window size class's state, just like any other state in a Compose application. And the real power of this is that you can change which UI to display in some very basic Kotlin code based on the window size class value. You can, of course, go beyond just doing that, and you can, use all of the tools Compose provides, like animations and hoisting state and reusable logic. But just for the sake of simplicity, let's just take a look at this very basic conditional here. So if your app is architected using multiple activities and you aren't ready to make this, migration to Compose just yet, using activity embedding is maybe a good option as a stopgap to display multiple activities from the same app side by side. Of course, space permitting. But the nice thing is the minimum space required to show both and define its behavior in configurations from the Window Manager library is up to you. You can define that and how that behavior actually exists. So the behavior of the embedded activities is gracefully it gracefully, how do you say that? It gracefully degrades below API level 31. So on API level 32 and onwards, you'll see them side by side. And sort of depending on whether it's supported on an older device or not, it'll just act like a regular stacked activity navigation. Now, if you're using Compose or fragments, where you have more direct control over your navigation structure, I want to kind of talk about the best way to think about the intersection between your primary navigation and the window size that you have available. So a solution that makes sense is probably to preserve the user's state while still being able to be flexible enough to show different content depending on the screen size. So one way of thinking about that is keeping your navigation structure fixed and independent of the screen size. So at each destination, the content displayed might match different depending on the screen size. So for each navigation step that I have here in my graph, I have those conditionals, right? That same if statement or that switch statement that I had, if compact, if medium, if expanded. And for each of those navigation steps, I am tailoring a experience dedicated for that window size class. For contrast, we can take a different approach, maybe something more based off of a notion of like, quote unquote, is tablet. Now again, this is definitely not recommended. I'm just trying to illustrate a counterpoint here. So the idea is to have like 2 separate navigation structure, one for phone and one for tablet, all right? The big issue here is that however you define is phone or is tablet, which is debatable in itself, is it doesn't have one answer, right? On a foldable device, an app might be displayed on the inner screen, might be considered a phone. On the outer screen, when it unfolds, it might be considered a tablet. In a desktop environment, the freely resizable app might be changing sizes arbitrarily, switching between compact and medium and expanded. So what does that mean for your navigation graph if you formulate it this way? Well, if it's still preserved to the user state, you'll end up needing to connect these two separate navigation graphs somehow, and preserving the user state, right, as you flip between them. Remember I was talking about like unfolding a foldable? Well, keeping that list in the same offset, but you have separate navigation graphs, I mean, it's doable. You can probably solve for those cases, but you're probably going to run into all sorts of side effects as screen sizes are changing sort of more fluidly. So to avoid that, and this is going back to that first diagram, you can keep the main spine of your navigation the same. And when you use the same size of the screen as an input to vary what is being displayed on each destination. And the important takeaway from this is that the main navigation may not be handling like all of your navigation, at least not from your user's perspective. It's more like for displaying something like a list detail or so, like you might have nested navigation with some destination which is handled separately from static navigation. But just as overall idea, as an overall concept, as you navigate through different parts of your application, you partition the window size classes at each individual node. So we have a great sample for this on GitHub coming up very soon. It's unfortunately not released quite yet. So stay tuned to the Android developers on Twitter or LinkedIn or wherever you get your media, now on Android. You can swing by our booth. We have a great demo running at the moment that shows this actually in practice, and we can bring up the code and show you how it actually works, and you'll see how actually incredibly easy this is in practice. So putting all this together, we had Tier 3 laying the groundwork to preserving the user state, then taking the window size into account and optimizing for your app's UI based on the screen size. Now with Tier 2, you can create better layouts that take advantage of these, the screen size and the different orientations, and as things change, folding states, that sort of thing. We have a wealth of resources available on these topics, and here's just a handful of links with the quality checklist and the design checklist, and there's some technical guidance there as well, getting your apps up to snuff to reach Tier 2. Excellent. Finally, Tier 1. An app reaching Tier 1 is really a differentiated experience. It's really, you have to think of it more like, it's making good use of everything that's available to it, including different input methods. So I really call this like an open-ended tier. Use cases really vary depending on what your application is trying to do. Just to set some examples, like think about media apps might be more interested in different postures. Think about like tabletop mode for watching media. Productivity apps might be thinking about making better use of keyboard shortcuts, or coexisting side by side in multiple instances, or mouse and stylus inputs. So the first differentiating experience that I would call out as a good example of, I think in general, just a good thing to do as your app coexists on the same screen with other apps, is thinking about drag and drop. So the APIs for enabling drag and drop have been around actually for a pretty long time. It's nothing new, but the new drag and drop library from Jetpack just went stable, and it makes it much easier to implement now. So both on the receiving side, so receiving drop data, but also on sending drop data, and we can take a look now what that actually looks like. So drag start helper is the utility class that detects gestures that are commonly associated with starting a drag gesture. So on a touch screen, that might be long pressing on some piece of content, or on a laptop using a mouse, it might be clicking and holding the mouse button. And you can easily set and customize the visual appearance of what is being dragged using the drag shadow builder. And in this case, I'm just using the default one, but you can customize this. Also note here, the global flag allows dragging data across apps. So since what I've done here is I'm actually providing a resource identifier of the schema content, and it's not just plain text. If it was plain text, it would be easy to do. But if you're actually trying to drag a file, like I am in this case, we need to use the drag flag global URI read to make sure that this data is available to other apps and they can be read from our content provider. So without it, other apps won't actually receive the drag events. The counterpart of the drop side is the new drop helper, which is a utility class that takes care of listeners and drop targets. An important thing to remember is the use of the add inner edit texts. And the reason this is important is because if a user is dragging into your drop target and your drop target contains edit text within it, it's possible that those edit texts will receive the drop focus. So by providing the drop helper options here for adding inner text, you can be sure that it'll behave accurately. Now, both of these helpers are primarily focused on views, but the built-in compose support is on the roadmap to take care of this and make it much easier for the compose side as well. On foldable devices, apps can observe the state of the folding features using the window manager as well. And again, we can use this state to basically adapt the UI on how the device is being physically positioned and folded. For instance, a media app, like I mentioned before, can move the playing section of the app, the actual playback of the video, to the vertical portion of the screen that's perpendicular to the table. And you could leave like the bottom part of the screen for like metadata and buttons like the like and dislike button here, or comments and that sort of thing on the bottom part of the screen. So apps that have distinct sets of content can support multiple instances of the same app simultaneously. We can make good use of multi-instance here. It allows the users to effectively have two different windows for different content and different accounts, for instance, or different profiles. And we actually saw some good examples of that with Francesco and Cesar's session this morning in productivity apps. And speaking about productivity apps, but also creative apps, we can optimize for many different peripherals and other forms of input, using rich keyboard input or mouse and stylus experiences, exposing more functionality and tools to users via shortcuts and contextual menus. So these have just been a few of the different ways where apps can really set themselves apart on larger screens. I know there are great ways out there that I haven't even begun to think of yet. You probably know those best. Really think about what differentiates your app on a larger screen. The diversity of devices of inputs for apps, they really provide an engaging and useful experience, and I really like seeing some great experiences on my tablet. So in summary, I hope this has been a helpful framework for you to begin to think about supporting larger screens in different tiers, how different libraries and concepts fit into that process. And remember, a user's device is their unique and personal portal into the digital world. So I think it's also our responsibility and our opportunity to provide great user experiences, however our users are choosing to interact with our apps. And that's really all I have. If you have any questions, please visit our booth where we have some great large screen devices for you to test with. We also have our code lab being demoed. Thank you very much for that, Guru. And we have many of my terrific teammates to answer questions much better than I can. So thank you so much for listening to.